Thanks a lot. So before starting my this presentation, I am very grateful to our respected Professor Praveen sir. So that give me the opportunity to interact with you. So this is my I am very fortunate. So for giving me provide me such type of opportunity. So let us, as we know, this is today's river sand is a very hot issue, and as we know that river sand, which is also called as the fine aggregate, also called as the natural aggregates. So it's commonly used in the concrete, but in the present scenario, it is becoming scarce and expensive due to the high cost of transportation from the natural sources. And this large scale excavation of the river sand also create serious environmental problems. And government is therefore restricting the collection of the river sand from the riverbed, forcing concrete industry to look for alternative materials as the fine aggregate, which can be effectively and sustainably used in the concrete as a fine aggregate. And as we think that whether this sand mining is a solution or a threat, so as the demand for the sand continues to increase, sand mining seems to have popped up as one perfect solution to meet the demand. But sand mining has been causing huge environmental damages, and extreme in-stream sand mining is causing degradation of river, and it is also lowering the stream bottom, which can ultimately lead to the bank erosion. Decreasing of sand in the stream bed and along the coastal areas can cause deepening of rivers and the expansion of the coastal inlets and river mouths. And saline water intrusion is another negative effects of the sand mining. The consequences of the mining is compounded by the effect of sea level rise. Also, any volume of sand exported from the stream beds and coastal areas is a damage to the system. And irresponsible sand mining is also a huge threat to the river banks, bridge, and nearby structures. It is also affects the nearby groundwater system and the uses that local residents make of the river. And sand mining can be responsible for the destruction of the riparian and aquatic habitats through huge change in the channel morphology. Effects include this bed coarsening, bed degradation, lowering water tables adjacent the stream bed, and the channel volatility. So and present day there is one another this as we know that this natural river sand was the cheapest resources of the sand. However, this excessive mining of the river bed to meet the increasing demand for the sand in construction industry has led to the ecological imbalance in the country. And now the sand available in the riverbed is also presently is very coarse and contains very high percentage of silt and clay contents. And as we know that this presence of the silt and clay, this strength of concrete is reduced, and also dampness is hold for a long duration. So this presently the stone industry, this is another aspect of this studies, that is the stone industry has been an integral part of the various progress made by the this human civilization. Stones of the different types have been used as infrastructure, building materials, and ornamental materials. And in the few decades, the infrastructure utilization of this stones has been this tremendously growth, and the production and processing of stone product such as in the aggregates, this floor slabs, this wall tiles, this results in the generation of a huge amount of stone processing dust. And simultaneously, on the other hand, the economic and environmental concern regarding the use of this natural fine aggregates have resulted in the this for the alternative aggregates from this various industrial byproducts or the waste material. So this basically figure shows the waste generation generated at the crushing plant. In this presentation, I have taken two videos which I will show you in later on. So basically, at the starting of this uh, any mining, any mines, so there will be the blasting for to obtain the this raw stones or bigger that at that time we this obtain the big size stones, and by using the crushers, different types. First of all, we use the primary crusher or jaw crushers to reduce the sizes. Then we use the impact crusher for processing to achieve whatever size we want. And after that, we use the sieves for grading purpose. And ultimately, there will be the some this waste product, that is the fine dust. So that is called as the, in our studies, the stone processing dust. So there are the various advantages of this stone processing dust. So that is basically a waste product that is generated during the manufacturing of the coarse aggregates. So that's why this is the cost effective. And nowadays the crusher plants for the these aggregates are established everywhere, and I think in the every city and nearby the city, so it is easily available. And if we use this stone processing dust in any form, in any product, to manufacturing any product, in our case, we will use this in the concrete. So definitely that will reduce the environmental pollution, and also that will reduce the pressure on the market demand of the natural fine aggregates. There are some disadvantages also of this uh, stone processing dust, that is basically having the high water absorption. In our case, the water absorption was more than 3%, and there are the large amount of the microfine particles, and definitely it is having the rough textures, and sometimes it is a cubical or angular shapes. So there are some environmental problems associated with this stone processing dust, and as we know that our environment should be protected from the man-made causes. So, and this is basically a very hot issue today, is that how we can sustain our environment, how we can retain as it is our environment, so that ecological the cycle cannot be disturbed, and human health cannot be suffer much more. So there are the some major issues related to the environment, this associated with the stone processing dust, that the emission of the dust at crushing plant cause extreme air contamination and may bring about airborne infection and diseases. And this stone crusher industry is considered as one of the most polluting industries of our country due to the poor control technologies for the dust emission and low technology penetration in the industry. The dust also this adversely affect visibility, reduce growth of vegetation, and hampers aesthetic view of the area. And this will show, we will visualize in video that I will play in after 3 or 4 slides after. So when the total amount of this particulates in the atmosphere increase, particulates may observe incoming solar radiations, and that may cause an increase in the atmosphere and land surface temperature. So that is one of the reason how the this temperature difference. And with the deposition of the aerosol on materials, the effect is expensive to remove deposited particulates which damages vegetations by preventing them from photosynthesis. And this also affects the road transport during the spring season because poor visibility is one of the reason, and there may be the sometimes causes the accidents, and dust settled over the equipments will cause rapid wear and tear of the rotating part, and there may be the corrosion of the this steel parts, and this may lead to frequent breakdowns and higher maintenance cost. The survey reveals that there is an adverse impact on the health of the stone crusher workers in terms of the diseases, like that. There may be the skin problem, eye problem, there may be the this diarrhea, or there may be the lung infections. So these may be the common problems. Sometimes आपने सुना होगा कि वर्कर्स के फेफड़े खराब हो गए, लंग्स में प्रॉब्लम हो गई, स्किन जो है उसका कलर चेंज हो गया, साथ में एलर्जी हो गई स्किन से. सो देयर आर दोस सम प्रॉब्लम्स दैट मे related to the health of the workers. And noise pollution is also the key factor for operating stone crusher plant, especially vibratory screen operating at high frequency, and when we do not use any enclosures. So these are the two basically videos, short videos that will show. First video will show the this how this crusher dust, or we can say that the stone processing dust is manufactured during the this manufacturing or production of the coarse aggregates. And second video will show you the how we can make the manufacturing sand. So basically, there is slightly difference of this of the stone processing dust and this manufacturing sand. Basically, what is this this stone processing dust and this manufacturing sand can be used as the potential as a fine aggregate, and that has been investigated in a decade for both the, and that this manufacturing sand and stone processing dust have different basically morphology, and this basic difference is that in the case of the manufacturing sand, this stone dust, or we can say that the powder means the particle size is less than 75 microns, are kept below the 10%. In the case of the manufacturing sand, the particle size less than the 75 microns should not be greater than the 10%. And this basically this crusher dust is or stone processing dust is basically having the flaky shape, and but in the case of the M sand, basically it is intentionally manufactured, so that's why it is called as the manufactured sand. And basically there is the wetting process. Actually क्या है कि this less than this 75 microns should not be more than 10%, achieved by basically partially washing out of the this basically this stone powders and before use. And this for this stone processing dust, no such pre-processing is done before use, and it carries a higher percentage of the stone powder, that is less than 75 microns. And other difference is that the there is the particle gradation usually affect this workability and this microstructure of the concrete. And basically in sometimes as we know, as per the IS 383, there are the 4 zones for the fine aggregate. Zone 1 is the coarser one, and zone 4 is the finer one. And generally when we manufactured this sand intentionally, then we try to kept in the zone 2. And for the case of the stone processing dust, depend on the your crusher plant that may lie in the sometimes it may be the zone 1, but it is very rare. But sometimes it is lie in the zone 3, or sometimes it may be the zone 4. So basically this is the difference. So now we will I am playing this short video of this how this dust or stone processing dust is manufactured during the. So this is a short video, and this is basically related to this Udaipur zone itself. There is a Mewar High Tech Engineering, and this is situated at nearby Udaipur, around 15 kilometers far away from the city. That is Umada. There is a location, or we can say that a short place. So first of all, this is the 120 ton per hours production of the this force aggregates, and simultaneously there will be the this production unintentionally production of the this stone processing dust. So we can visualize from this figure that this dust is mixing in the air or flowing in the air. So that will definitely responsible for the air pollution. And at the time of the crushing of this such type of stones, there are the so many noise created, so many unwanted noise. So that is also responsible for the this uh, noise pollution also. So we can visualize that there is no control on the dust particles, and
सर वीडियो रुक गया। गुप्ता सर वीडियो रुक गया, पॉज हो गया गलती से, या कहीं वैसे अटक गया नेटवर्क की स्पीड से लगता है। सर आपका स्क्रीन भी शेयरिंग वापस करना होगा सर, आपका शेयर स्क्रीन भी हट गया किसी कारण से, लग रहा है नेटवर्क की स्पीड या कोई और इशू हो गया है आपके एंड पे। त्रिलोक गुप्ता सर सुन पा रहे हैं सर? आपको स्क्रीन दोबारा शेयर करना है सर, कहीं कुछ बाहर निकल गए हैं। मुझे लग रहा है उनके यहाँ कुछ अनइंटेंशनली कुछ इश्यूज आ गए हैं, तो अभी रिजॉइन करते हैं वापस। In the meantime, I may share with the participants that as he has already pointed out, ISCHC has some provisions, particularly in 2016 version, for using stone processing dust as the fine aggregate. One is to keep those considerations into mind. In some cases, particularly when your crusher dust is of a suitable gradation, suitable particle size distribution, one may find it very much useful. In my PhD work also, which I did at IIT Roorkee about 17 years ago, 17, 18 years ago, we did use and produced at that time, 2002, 2003, it was very much normal to get 90 MPa self-compacting concrete with pressure dust. So that was, you can say that used to come from Jwalapur crushers. If somebody has been in that area, when we go to Haridwar, some 10 kilometers before Haridwar, there are a lot of so many crushers and 4-5 crushers at that time. So I took crusher dust from those crushers and found it very much useful. So the other things which Dr. Trilok ji will share about the durability aspects, that must be taken into account. I did extensive studies on microstructure of concrete as well, fatigue performance as well. So that may be shared if time permits, anytime with you people with all these sustainable materials. So my publications are also there, which you can see. I talked about marginal materials. So, good morning. Bharat Shinde ji.
हाँ अगर बधाने ज्वाइन थवा दो क्लास समझिए પછી ઇન્સ્ટ્રક્શન આપો
So Professor Nagaraj's paper, Professor Jagdish paper, these have been the earlier investigators in the country who has worked upon the mechanical properties and durabilities. But of course, as Dr. Trilok ji has been presenting, and he has rightly talked about that in most of the cases, if you wish to use in bulk quantity, one has to wash these aggregates. I remember when I took first time my college students here, BTech students, to the Rajasthan Atomic Power Project site, unit number 3 and 4 in 93, at that time in construction. Unit 3 and 4 of Rawat Bhatta Atomic Power Project was in construction stage in 93. So I took first time the students there. RAPP first time allowed such large number of students. So at that time also, in Rawat Bhatta Atomic Power Plant construction, this stone dust was being washed and used. That was 93. And since then, Atomic Power Project has built 5 and 6 unit, 7th and 8th unit at Rawat Bhatta and other locations of the country as well. So when atomic power station construction can use, that means they first ensure themselves of any lacuna, then only they can use. So there was no lacuna. And then recently in 2018, everybody of you knows that being university, we get many jobs as third-party inspections, etc. So 2017-18, we visited many works in Jhalawad area, a nearby area. There, the superintending engineer, Mr. Jhawarji, was there. I think some of the participants knows him. So he rang me personally that when you are going there, please find time to visit our plant, visit a plant there producing fine aggregate from crusher dust, which was being washed there. आप में से कई लोगों ने कुओं पे घरट देखी होगी, वैसा का वैसा बकेट्स का उन्होंने एक अरेंजमेंट कर रखा था उस प्लांट में और वो उससे उसको वॉश करते थे. बहुत ही अच्छा लगा था कि पीडब्ल्यूडी जैसे डिपार्टमेंट्स लाइक पीडब्ल्यूडी in India, in particular in Rajasthan, were promoting such fine aggregates and was at the highest level, PIU level, they were monitoring this thing and they were taking keen interest. So, जहाँ चाह है वहाँ राह है, तो इसलिए आप लोगों को यही कहा जाता है कि जब अगर कोई इंटरेस्ट लेता है इंजीनियर इंचार्ज साइट पे या कोई भी, मैं कहता हूँ फैकल्टी भी इंटरेस्ट लेगी, तो उसके आसपास के वर्क्स में उसका प्रभाव पड़ता है। मैं एक बार त्रिलोक जी सर को लिंक करता हूँ, देखता हूँ क्या हुआ है। उन्होंने फोन काटा है, तो या तो कुछ इशू है, वो देख रहे हैं शायद। एनीवे, ही विल ज्वाइन। सो मैं ये जिक्र कर रहा था कि ये जरूरी नहीं है कि स्टोन क्रशर डस्ट से आप ज्यादा हाई स्ट्रेंथ कंक्रीट नहीं बना सकते या ड्यूरेबल कंक्रीट नहीं बना सकते। इट इज माय ओन एक्सपीरियंस दैट आई कुड मेक about 90 MPa concrete, and in some mixes I could get 100 MPa as well. My paper was published in the first North American conference, Chicago, in 2005 with 100 MPa self-compacting concrete, of course with crusher dust. So that way I can assure you that if proper mixed proportioning is done, we can get proper concrete. And microstructure has been my favorite subject, and I have tested not less than 3,000-4,000 samples. So I can assure you that there's we can engineer the mixes and we can get proper concrete with mix of materials being talked in this FDP. Recently, my two MTech students are working in waste plastics in concrete, and they have indigenously developed some technologies, and we got overwhelmed when the first results came about 6 months back, means just before lockdown rather, and we could not believe that in January, February when we got those results. Then we have repeated those experiments even during lockdown, during July, August, etc. So they are just on the finishing line on those MTech students. So this is just to share what we are doing here. I have just talked with Dr. Pateria sir, who will join at 12 noon with us. And of course, many of you are aware that our institute, our university does technical scrutiny of PMGSY road proposals for 11 districts since last 15 years. Luckily, I am associated with that. So in last, say, phase 2, phase 3, what we have done is that PMGSY, that is rural roads, it has become compulsory in each block. There must be one road, at least one proposal, at least with the plastic waste in road construction. Previously, and one, at least one road which must use new technologies. So among the new technologies, of course, this Flyash in roads has been propagated in this PMGSY. Any participant, if wish to contribute his experiences, his other experiences, is welcome. Seems Gupta Saab might have struck at some point in maybe in his official work. I will again ring him. In the meantime, if any of you wish to share his or her experiences, research experiences, you are welcome. And one more announcement, as I have written in the circular, that as per the AICTE condition, we shall be organizing an online test at the end of the FDP. I'm just working on the modalities, whether it will be on Google Form or Moodle. I think many of you are familiar with the Moodle as well. So let me check whether it is possible, which one of these two will be more comfortable to you. And of course, Google Form is very much, you are all seems very much familiar with this. Any suggestions regarding that may be given me on my WhatsApp or personally on mail. That shall be announced by tonight circulars. When I will share you the link of tomorrow's feedback, I may share you the test paper modalities as well. So every one of you are aware that those of you who are from faculty participants from the institutions, that AICTE will issue the certificate of participation directly to you. The conditions for issuance of certificate of participation is that coordinator will fill the attendance, and we will fill the test marks of all the participants. AICTE conditions are that 80% is the minimum attendance and 60% are the minimum marks, say 60% marks must be at least obtained by the participant to earn their certificate. That will be done. I am sure that every one of you will be doing that. Just to repeat that condition. And of course, I have to post the news updates and short videos and all those things. So those things shall be done in some 1 week or 10 days time. So please be patient. After the finishing of the FDP, it may take me to complete the formalities at the AICTE portal of mine, maybe in 1 week or 10 days. And then AICTE will issue you, will generate the certificates and it will reach to you directly. In case you do not get the certificate in, say, 2 weeks time even, then you may just remind me on my WhatsApp number or this email. If issue is there, I will resolve that. And I look forward to continue association with most of you, because many of you are participating with vigor. Anyway, let me ring Trilok sir again. In fact, when I ring him just now, Trilok sir picked up, and he did not knew that he has come out of the presentation. So he will join again.
सॉरी सर, शायद नेटवर्क कनेक्शन की वजह से मैं आउट हो गया था
सर।
हाँ सॉरी, हाँ सर, मैं अब कंटिन्यू करता हूँ
सर। आ गया सर, आपका स्क्रीन आ गया सर।
ओके, सो आई थिंक वी हैव डिस्कस दिस कंक्रीट मिक्स प्रोपोर्शंस, और पहले चला गया था सर?
सर पहले ही आपका वीडियो चल रहा था, उसके दौरान चले गए थे सर। वीडियो जो आपने,
वीडियो के बाद चला गया था?
हाँ, वीडियो भी पूरा नहीं हो पाया था। एनीवे, जस्ट वीडियो के जस्ट बाद का पोर्शन ले लीजिए सर।
ओके ओके ओके
सर।
सॉरी, मुझे आइडिया नहीं लगा, मैं बाहर
नहीं, वो सब हो जाता है सर, सबके साथ हो जाता है।
हाँ नहीं, सो बेसिकली इन द दिस, जस्ट अ मिनट, मैं इसको, so in the current basically study, we replace this natural fine aggregates by the stone processing dust up to the we use the 100% replacement in the increment of the 10%, and we find out different types of mechanical properties and this durability properties on this stone processing dust concrete, and finally we have this calculated the economical and ecological aspects of the stone processing dust. So in the this study, we used normal OPC cement of the 43 grade, and these are the properties and initial setting time, final setting time. The 7 days compressive strength of the this cement was the 34 MPa, and 28 days compressive strength was the 44 MPa. Consistency was the 30%, and specific gravity was the 3.11. Normal OPC cement of this Ultratech was used, and river-based this sand was used as fine aggregate, and this stone processing dust was obtained from the local stone crushing plant, and the stone processing dust particles had a higher amount of fine particles and also exhibited rough and angular nature than the fine aggregates. So these are the physical table shows the physical properties of the aggregates. The specific gravity of fine aggregate was the 2.64, and stone processing dust was having a specific gravity of 2.56, whereas the coarse aggregate was having this 2.71 specific gravity. All material was obtained from the local this natural fine aggregate was obtained from the local river nearby Kharka river, and stone processing dust was obtained from the local crusher plant that is around nearby, around 15 kilometers from the city, and coarse aggregate from the same plant, and this water absorptions was the 3.2% for the stone processing dust as compared to the 0.8% of the natural fine aggregates. So that was the too much due to the presence of the fine particles, and coarse aggregate was having normal 0.7% this water absorptions, and fineness modulus was the 2.7, 3.3, and 3.04. So this figure represent the gradation curve of the fine aggregate as well as the stone processing dust. So as per the IS 383 code, this both the fine aggregate as well as the stone processing dust was lie in the zone 2. As you know that zone 1 is the coarser one, and zone 4 is the finer one, and code does not recommend to use the zone 4 sand in the concrete. As we know that there is some grain size distribution, we can classify our grades of any kind of aggregates, whether it may be the coarse or whether it may be the fine. In the three, basically poor graded, where only one type of or one size of aggregates or size is available, particle size available. And if there is gap graded, is called where when one or two size is missing in the particle size, and when all type of size are available in the this aggregate, whether it may be the fine or coarse, so that is called as a well graded. So according to this curve, our this fine aggregate as well as the stone processing dust lie in the this well graded. And this is the gradation classification of the fine aggregate as per the IS 383. So there are the four classifications: zone 1, 2, 3, 4, and 4 is the finer one. So we will not discuss now. This is the important curve basically. Now this curve or figure or graph represent the replacement level of the stone processing dust. So we can observe from this curve that this fine aggregate having very this less fine particles, means less than 90 microns are quantity or percentage is less, passing than 90 microns. But when we goes up to the 100%, so there are much more fine particles as compared to the this natural river sand. So now concrete mix design was carried out as per the guidelines of the IS 10262, and we replaced the natural fine aggregates by stone processing dust in the increment of the 10%, and we goes up to the 100%. And this as from the last table, that water absorption for the stone processing dust was around 4 times of the natural river sand. So that's why we use to maintain the same similar water cement ratio. In the study we used the 0.45 water cement ratio. So we use compensatory water, means top up in the mixing water was added to concrete mix to counter water absorption of the aggregates, so that same water cement ratio can be maintained. And normally casting was this done as per standard practice. We cast mold, left for 24 hours, then we submerge into the water till the testing. Now this is the figure shows the concrete mix proportions from 0% replacement to the 100% replacement. We used 339 kg per meter cube this quantity of the cement in the concrete, and the ratio was the 1:2.19, and coarse aggregate was the 3.68, and water cement ratio was the 0.45. And we used this mechanical properties. We calculate the mechanical properties, compressive strength and flexure strength. These are the basic properties. Just a minute. Compressive strength was performed on the 100 mm cubes, and flexure strength on the beam specimens size of 100 mm by 100 mm by 500 mm. And the curing period for the flexure strength was that only 2, that was the 7 days and 28 days. And for the compressive strength, we perform compressive strength, or we calculate compressive strength on the three for different 3 curing periods. That was 7 days, 28 days, and 90 days. And static modulus of elasticity was calculated only for the 1 curing period, that was the 28 days. And it was calculated or determined on the cylindrical specimens having diameter of the 150 mm and the height 300 mm, and the code for the this static modulus was followed ASTM C469. Three specimens were tested for each type of test. The next, we calculate the abrasion resistance in the terms of the depth of wear as per the 1237 on the this size of the cubes was the 100 mm, and depth of wear as per the 1237 IS 1237, that was the difference of the weight loss. We can say that initial mass minus final mass and into the volume, initial volume, and divided by the initial mass into the area. So after that we find out the depth of wear in terms of the mm. So that is basically abrasion testing machine that was used to calculate the abrasion resistance. After that, to find out the ductile properties, we use the impact resistance by using the drop weight test. As per the ACI, American Concrete Institute 544, basically this type of equipment was used, apparatus was used to calculate the drop weight. So in this, basically we use the cylindrical specimens having diameter of 150 mm, height was only 75 mm, and we drop the ball, this hammer ball that is having the weight of the 10 pound, around 4.5 kg, and height of fall or drop was the 450 mm, 0.45 meter. So we note down the this how much number of blows are required or number of falls are required to this for the first crack as well as the ultimate failure. Means at the time of how much single crack, hairline cracks, how much number of blows or number of counts required to develop the single crack, initial crack. So that was noted as the N1. And after that, we continue the testing process and we calculate the or we count the number of this drop or blows. How much at the how much blows it will be the ultimate failure. It will be the breakdown in number of pieces, means more than 2 number of pieces. And normally impact energy was calculated by using this MGH. M is the mass of the ball, that was the 4.5 kg. In the as per the American or British standard, they generally use the pound, so that's why that is the 10 pound. So, and G is the acceleration, and H is the height of fall, that was the 450 mm. And we multiply simple N1 or N2 to find out the impact energy at the first crack or at the ultimate failure. And this we also calculate the water permeability, and this was obtained on the 150 mm cube size as per the German code of the this DIN 1048. And we used this 150 mm cubes before the testing. We first of all we put the specimen in the oven for 3 days at the 60-degree temperature, and after that we start the test, and the duration of test was the 3 days, 72 hours. And we apply the water with the pressure of the 5 kg per centimeter square. And after 3 days, we this split out in the 2 halves. We break down this cube in the 2 halves, and we simply measure by using the normal scale how much depth penetrate into the concrete, and we note the average depth of the water penetration. And ultimately, this to calculate the sustainability and economic aspect of this concrete containing stone processing dust, and analysis was carried carried out in terms of the embodied energy and this CO2 emission. And so that after that we also calculate the cost analysis, whether this will be the cost effective and whether it will not be the cost effective. As in this case, basically the stone processing dust is obtained by a product of as a byproduct of this industrial process. So its energy and environment impact was not considered, because definitely this is a waste product, so that's why this is not considered in this study. And after this at the last we will observe this thing, and this current product and this transportation cost is India were considered for cost analysis of this all type of concrete making product. Now this is the water permeability test apparatus. Now we comes to the this our result and discussion parts, that this figure shows the compressive strength of concrete containing stone processing dust up to the 100% replacement. So we can observe from this figure that up to the 30%, this from zero, we can take any type of, let's say we take the 90 days strength, so or 28 days strength, so it was around 26 approximately, but it goes up to the approximately 33 up to the replacement of the this 30. After that percent, it was greater than the 0% replacement, and after that means at the 80%, 90% or 100% replacement, it was less than the control mix. And we can say that this 30% replacement, at the 30% replacement, the compressive strength was around more than 31%. At the 30% replacement, the compressive strength was more than the 30%. Basically, the main reason for this for stone processing dust based on this improvement in the compressive strength is the higher amount of finer particles in the concrete mix. And the filler actions play an important roles. Important roles in reducing the voids between this gaps and cement paste. The best mechanical performance is exhibited by a dense concrete matrix. Since higher compactness usually translate to higher strength characteristics, stone processing dust concrete becomes denser owing to the higher amount of fine particles, that is below means less than the 600 microns. The fine particle improve the packing density and the interfacial transition zone of the hardened concrete, basically. And for higher replacement of this stone processing dust, that is means greater than 70%, the higher amount of fines left after filling the voids. Means after filling the voids, there are again much more fine particles, that is increase in the cement paste to particle ratio, and thereby resulting in the lower compressive strength. And additionally, the angular nature of the stone processing dust increases the surface area to be covered by the cement paste, thereby causing the development of the voids. And these voids have a weaker plane, which leads to low compressive strength. Furthermore, this angularity of stone processing dust also lowers the compactness of the concrete by increasing the interparticle friction. And now this figure shows the flexure strength of the concrete. Here we can observe up to the this 30% replacement, it is greater than as compared to the control mix. After that, it goes down. And at the this from figure, we can observe that this around this 50%, it was nearby control, but after that it was goes down. So basically up to this at the replacement of 30%, there was the increment of the 8.5%. At this 0%, the this flexure strength was around 4.6, and it goes around 5.6 at the this 30% replacement. But after that, it goes down for the 28 days. And as compared to this compressive strength, the mechanism of the flexure strength loading is quite different. And this basically is similar. However, a similar trend was observed between the flexure strength and the compressive strength, and up to the this 30% replacement. Basically, this is the same region because of the particle packing. And this fine particles of stone processing dust acts like filler by filling the voids between the cement paste and aggregates, and thus strengthen the concrete specimen. And furthermore, basically this enhance the compactness, increase the flexure load carrying capacity of concrete containing stone processing dust. And we can say that this enhance the compactness, improve the this interfacial transition zone ITZ zone characteristics of concrete, which help in the increased capacity of carry the flexure loading. Now this is the next figure that shows the 28 days static modulus of elasticity of this concrete. Again, we can observe from the figure that it is increasing, means it is highest we achieved at the 30%, and after that it goes down, and approximately this 70%. After the 70%, it was less than the control mix. And basically, this static modulus of elasticity depends on the various factors, and such that this type of coarse aggregate, mortar paste stiffness, bond between aggregates, mortar matrix, and void porosity of concrete. So since the type of coarse aggregate remains, we have taken the same out throughout the study. Rest three factors. This mortar paste stiffness, bond between aggregate and mortar, and void porosity of concrete. It is very important, play an important role in influencing the elasticity modulus of the stone processing dust concrete. The addition of finer particles containing stone processing dust improves the microstructure of concrete, thereby providing better bonding characteristics between aggregate and mortar matrix. This dense concrete matrix, due to flare action of the fine particles of the stone processing dust, presents higher stiffness of mortar paste, increase the elasticity of concrete, and definitely that's why we got this higher static modulus of elasticity up to the 70%. So this this was the now we comes to the impact resistance. This figure shows the number of blows for the concrete containing this stone processing dust. This black graph shows the N1, that is the number of blows required at the time of first crack, and this green N2 shows the represents the this number of blows required for the ultimate failure. From this figure, we can visualize that this up to 40% similar to the this we can say that similar to the control mix, that is not much more affected. But for concrete mixes containing this stone processing dust higher than 40%, the amount of this blows, or we can say that the impact energy is less than the control mix. So we can observe that after the 40%, there is that decrease in the impact energy. This impact resistance of concrete depends on this paste aggregate contact area and bond, how much stiff bond is there, and a solid concrete matrix enhance these properties, and which are instrumental in resisting the propagation of the cracks. And for concrete mix containing up to the 40% this stone processing dust, the flare particles densify the cement paste matrix, thereby improving its bond characteristics with the aggregates. And in case of the higher substitution, means more than 40% substitution, the angularity of the aggregates leads to the creation of voids, which provide easy access to the development of cracks. And there may be the further voids facilitate the faster development of cracks, as higher amount of voids accelerate the propagation of voids. Now it comes to the abrasion resistance, and this again figure shows the abrasion resistance in terms of the depth of beer. So up to in this case up to 20% only, that is nearby the, or we can say that the similar values as compared to the control mix. Beyond that, the depth of wear is increasing means abrasion resistance is decreasing. And this maybe due to the again higher amount of the fine particles which is having the tendency to basically high resistance up to the 20%, but beyond that this mortar paste containing a high amount of fine particles get easily eroded when exposed to abrasive force. The fine particles lost between granular voids are removed from the pockets during the abrasive actions, and this may be increase the depth of wear. And the voids in a higher amount of stone processing dust concrete also lower the abrasion resistance of concrete, as due to the chipping action of the abrasive force that ultimately weakened the bond of the main body. And this as per the IS 1237 for the as per the IS 1237, this heavy duty floors allow the average depth of beer is less than or up to equal to the 2 mm, and in our case the values was less than 1.1 mm or approximately up to the 1.1 mm, even up to the replacement level of the 100%. So we can classify it into, or we can use such type of concrete in the concrete up to the 100% replacement. Now in the next category, we find out the water permeability in terms of the water penetration depth. And as we know that this water permeability or water penetration depth provide insight on the durability potential of concrete against ingress of the harmful external agents, which can severely compromise the service life of the concrete elements, or that may be the ultimately responsible for the corrosion because of the ingress of this water into the concrete, as well as the chloride ions, as well as for the air voids. So such type of combination may lead to the corrosion. And this from this figure we can observe that at the replacement level of 30% there was the lowest value of the water penetration. So 30% is in our study was replacement was good enough, but if we goes up to even 90%, so that is that was the less than the control mix. So we can replace even up to 90% in, if we consider water permeability as an important factor for the durability. And however, replacement of the 100% was more than the this water penetration depth at the replacement level of the 100% was more than the control mix. According to to one researcher, that is Benjian et al., that is classified this water penetration depth into the three classes. That classified if the water penetration depth is less than 30 mm, that is in the category of low permeability. If it is in between 30 to 60 mm, then it may be classified into the medium permeability. If it is more than 60 mm, then it may be the high permeability. And in our case, in all the cases, it was less than the 30 mm. So we can say that it was the our concrete was having the low permeability. And the increase in water penetration depth value, this can be due to the high water absorption of the this stone processing dust, and this coloration effect for measuring the water penetration depth value can be influenced by how the saturated particles of the stone processing dust, and the formation of voids due to the angularity of soil processing dust also causes higher amount of the water penetration. Now, the important aspect of this our study was the ecological, and this values we calculated ecological in terms of the two values, that was the embodied energy and another was the carbon dioxide emission. Just and this was calculated for the 1 cubic meter concrete, one for the 1 cubic meter concrete. And from this table shows the embodied energy analysis of the stone processing dust. And from this figure, we can as we know that this stone processing dust is a byproduct of the stone crushing plant, or is used as we received from the plant. So that's why we do not take any type of embedded energy required for this stone processing dust, because it is a byproduct. And whereas other this embedded energy for the OPC fine aggregates, and this we have taken from one studies carried out by Mithun et al., and we have taken from that research. So for that in that research, it was given that 4.8 metric joule energy is required to produce the 1 kg cement, whereas in case of the fine aggregate, coarse aggregate, it is very less. And in case of the water, we required some filtration, and it required some pumping from filtration plant to elevated service reservoir, and from that to gravitational force is required. So that's why it is very, very less. So ultimately, if we observed from this figure, that is shown that embedded energy required for 30% replacement is less than the 0% replacement, or at the definitely at the 100% replacement, it is lowest value as compared to the control mix. Similarly, we also calculated this carbon dioxide emission during the production of the OPC or fine aggregate or coarse aggregate or this water. So again, we can observe that there is the 0.93 kg production of CO2 at the time of production of 1 kg cement. In case of the fine aggregate, coarse aggregate and water, it is very, very less. So if we visualize or observe from this table that we required 325, there is the 325 kg CO2 emission during when we do not use any type of stone processing dust. But when we use this 100% replacement or 30%, it is less than the control or 0% replacement. Now we have also calculated the cost analysis for this type of concrete, and this is based on the 2018 study. Basically, this study was carried out in the year 2018. So the rates for this OPC, fine aggregate, stone processing dust, basically only transportation was considered in that case, and cost saving was we can observe from this table or analysis, we can say that per cubic meter Indian rupee is required 3,256 for the when we do not replace anything. Anything means fine aggregate by the stone processing dust. However, when we use this 30% replacement goes, then there will be the reduction, and up to this 100% there was a huge reduction. We can say that around means 3.5% reduction was observed at the 30% replacement, and there was around more than 11% cost saving at the 100% replacement. This performance in this was also calculated for this study, and basically one represents for the control mix, and if the values are greater than 1, then it shows the positive impact, and if the values are less than 1, so it shows the negative impact on the concrete. So from this figure we can observe that this round shape bubble is represent the 100%, and we can observe that this compressive strength was less than control mix, so hence it is less than 1, and it is nearby 0.7, or we can say that the 70% only 70% strength was achieved at the 100% replacement level for the compressive strength. So like this way we calculated all other parameters, and if we are talking in terms of the better concrete, then we can go for the 30% replacement, and if we want to utilize maximum this stone processing dust, then we can go for the 70% replacement. So now it comes to the conclusion part. Now this as compared to this natural fine aggregates, the stone processing dust contained a higher amount of fine particles and has the higher water absorption capacity, and result shows that the increasing the percentage up to the 70% of the stone processing dust, the compressive and flexure strength of concrete improves, and the densification of concrete structure due to Floer action of the fine particles was considered as the major causes. The reduced voids and improved bonding between cement paste and aggregates due to the fine particles of stone processing dust resulted in the improved elastic modulus of concrete. Stone processing dust did not play a significant role in affecting the impact resistance of concrete. However, at the higher percentage means greater than 70%, the voids in concrete due to angularity of stone processing dust lowered the impact resistance. The abrasion resistance of concrete was negatively affect the stone processing dust. The chipping action of abrasion was predominant in dislodging the rough particles of stone processing dust from the concrete matrix. The depth of water penetration was lowered in the concrete containing stone processing dust as the fine particles block the pores and capillary voids in the concrete matrix. The economical and sustainability index of concrete can be boosted on the utilization of stone processing dust as fine aggregate. Finally, we can conclude that in stone processing dust up to the 60% can be used without much more affect the durability and mechanical properties to produce the structural concrete, and up to the 30% can be used for development of the paver blocks or pavement material, because there was a reduction in the flexure strength after the 30%. Now we comes to our second part. I think there is only 15 minutes left, so we go quickly in the when we use this waste material, waste rubber tires in the concrete as partial replacement of the fine aggregate. So basically, we know that the concrete is a brittle material and high flexibility is required. Higher impact resistance or higher fatigue resistance required in many applications. Apart from the strength, where strength is not major concern in some applications, and we required higher flexibility. At that time, which type of concrete we can use? So for evaluate or to determine the properties of such type of concrete, we use the waste rubber tire in concrete in two forms. One was this is the normal properties of cement. This is the basically sieve analysis, and this is the chemical compositions of the fine aggregate, which is having silica the 80%, and normal coarse aggregate of a specific gravity 2.59 was used, and nominal size was the 20 and 10 mm. Now it comes to the our this waste material. Basically, in this study, we used the two types of waste rubber material, waste rubber tire material. First was the rubber ash. That was basically obtained by the pyrolysis technique. Basically, that is incineration waste rubber tires at the control temperature of around 850 degrees Celsius for the 3 days. And results, basically, the specific gravity was only 1.33, and size was in between 0.5 and absorption was only 0.3%. These are chemical compositions that is having carbon contains around 65%. Okay. Now, another form of this waste rubber tire was used in this study was the rubber fibers. Specific gravity was 1.07 and water absorption was 0.4%. Same by using the same waste rubber tires, and that was obtained by the mechanical grinding. In the to obtain this rubber ash, we use the pyrolysis technique, but in this to obtain this rubber fibers, we simply use the mechanical grinding of the waste rubber. Tensile strength was 20.8 MPa, whereas size was in width was 2 mm to 5 mm, and length was around 20 mm. The aspect ratio was 4 to 10. Aspect ratio is the ratio of length to width or diameter. Specific gravity 1.07, water absorption 0.4, and lies in the zone 2. There was the higher percentage of the carbon because there was no heating process, so that's why carbon contains was 87%. Now, mixed details. In that case, we cast two series. In the case one or series one, we kept this water cement ratio 0.45, and in the second series, water cement ratio was 0.45, and in the first series, we replaced the rubber ash in the increment of 5% up to the 20%. And this cement content was 364 fine aggregates, coarse aggregates, and we use the super plasticizer to maintain the workability or compaction factor nearby 0.9. And now the density, the result, this graph shows the density of the waste rubber concrete in which we use the rubber ash and rubber fiber. We replace the rubber aggregate up to the 20%, rubber ash up to the 20%, but in case of the rubber fiber, we goes up to the 25%. So that's why in the last figure, there is only for the single result. Now, from the figure, we can observe that this density was decreased when we increase the percentage of the waste rubber. And definitely at the higher replacement level, we can obtain the lightweight concrete as compared to the control mix. The reduction density maybe was due to the this low specific gravity of rubber particles, increase in rubber waste contents, increase the air content, which in turn reduce the density of specimens. Compressive strength was again calculated. The figure shows the 28 days compressive strength, and this reduction again was observed in case of the rubber ash as well as the rubber fiber. But in case of the rubber fiber, there was the much more reduction as compared to the rubber ash concrete. And the reason was this presence of the softer rubber particles than surrounding cement matrix, and lack of adhesion between rubber particles and cement paste, due to which rubber particles act like voids and reduce concrete matrix density. This is the 365 days compressive strength. Now we comes to the flexural strength, and again flexural strength was, sorry, in the case of the rubber ash, there was the decrease in the flexural strength, but in case of the rubber fiber concrete, there was the increase in the this flexural strength, because this rubber fiber act as the bridge. So that's why there was the increase in the flexural strength in case of the rubber fiber concrete. Now, abrasion resistance, so depth of wear increase with the increase in the this replacement level of the rubber ash, whereas decrease with increase in the replacement level of rubber fibers, because it was very difficult to this abrade or this rubber fiber concrete. Now, the figure, these are the some scan microscopic images scanning. So this figure shows the rubber ash particles at the magnification of the 1840, and we can visualize there was the gap in between the rubber ash and the this cement paste, and that was the region of the this reduction in the compressive strength. And we can observe from this figure that there was the crack in between rubber ash particles and cement paste. Again, there is gap and cracks. The rubber ash concrete, in case of the rubber fiber, again there was, because due to the hydrophobic nature of the rubber particles, this gap was created. So we can treat this type of particles. So in this study, no treatment was used, and there is no results of the treatment. The figure shows the water penetration depth of the this waste rubber concrete at the 0.45 water cement ratio, and this depth of water penetration increases with the increase in the replacement level of waste rubber content for all the water cement ratio. This increase in water permeability was attributed to reduction in bonding between particles in modified concrete and higher amount of air voids entrapped around the rubber surface. Now, drying shrinkage was also calculated. This figure shows the drying shrinkage, carbonation depth was also calculated, and we can observe that the increase in the replacement level, there was the increase in the carbonation depth. However, we can, as we know that this carbonation in itself is not detrimental effect on the concrete. However, it reduces the pH of concrete, and due to which this corrosion, risk of corrosion is increased. And this increase in carbonation depth was attributed to the higher water content of rubber contents needed to maintain the workability in all mixes, and greater voids volume between the rubber aggregates and cement matrix. Static modulus was also evaluated, and it was again decreased, as this is dependent properties of the compressive strength. And basic reason was this lower modulus of elasticity of the this new, whatever we have added new materials, that was the softer material as compared to the this. Now we comes to the other properties, that is the impact resistance. if we observed from this figure that number of blows are much more required as compared to the control concrete, which is the positive sign. In case where we required this type of concrete, where much more impact energy is required. So this is the basically impact energy calculated. We can observe that around 100%. Okay, 100% increment in the case of the 20% replacement of rubber aggregate, and in case of the rubber fiber concrete, there was the around 4 times increase in the impact resistance. So like the crash barrier or curb stones, where where the collision of the vehicles may happen. So at that time we can use such type of concrete. And increase in impact energy resistance may be due to this less brittleness and much lower elastic modulus of rubber aggregates, which increase the impact resistance, and ability of the rubber to absorb dynamic energy, increase the strength of concrete under impact loading. This was the failure pattern in case of the rubber, waste rubber concrete. In the case of the control, first figure shows the control concrete, there was the brittle failure, and in case of the 25% rubber fiber, there was the means we can say that the ductile failure. Now the fatigue strength was also calculated at the frequency of the 5 Hz, and we can observe that there was a 3 stress level ratio, and we will because due to the limitation of times, will not discuss much more in detail. So again, fatigue resistance was also increased in case of the rubber ash concrete as well as in case of the rubber fiber concrete. But in case of the rubber fiber concrete, there was the much more increment. And this increase in the fatigue strength may be due to the rubber particles we able to absorb more energy subjected to the fatigue loading, which also reduce the probability of internal crack propagation and preventing the aggregate segregation with the waste rubber particles. Now conclusions, we can conclude that workability, if we use the superplasticizers, then workability was not affected, but in case of the rubber ash, there was the decrease. And partial replacement of fine aggregate by rubber ash and rubber fiber concrete decreased the compressive strength, and in case of the flexure strength, rubber ash concrete decreased the flexure strength, but in case of the rubber fiber concrete, there was the enhancement or increment. The maximum depth of wear in rubber ash and rubber fiber concrete is less than permissible limit. The water permeability remains in the category of medium permeability. And rubber ash and rubber fiber particles increase the drying shrinkage. The observed carbonation depth for rubber ash and rubber fiber concrete in the most adverse condition is less than minimum cover required. The reduction in static and dynamic modulus shows the higher flexibility. Impact resistance of concrete improve on replacement of fine aggregate by rubber ash and rubber fiber contains. Fatigue strength of concrete improves on the replacement of fine aggregate by rubber ash and rubber fiber contains. And we can conclude from this study, then fine aggregate can be replaced by the rubber fiber and rubber ash, where ductility is of the prime concern, where strength is not the prime concern and ductility is the prime concern. Rubberized concrete can be used in the partition walls due to the lightweight, pedestrian block, residential driveway due to the higher flexure strength in case of the rubber fiber concrete, garage floor, highway crash barrier due to the better impact resistance, and machine foundation due to the better fatigue resistance. So thank you. I think I have taken much more time. So
Thank you,
now,
Dr. Gupta sir. Any questions by the participants if they wish to inquire, sir? Participants are invited to ask any queries. The speaker, they can ask directly by writing chat.
yeah,
in chat
any
box,
query you can ask.
participants many times takes time to ask any queries. However, this presentation has been of immense use in today's situation. So any participant or any this say our esteemed resource person, Dr. Hegde ji, Dr. Bhavna Tripathi ji are also here. So if they wish to contribute or add something, they are most welcome.
Hello.
पूछिए.
Yes, sir. Yes, sir.
Am I audible?
Yeah.
Yeah. You were talking about rubberized concrete. Is it being used anywhere?
Sir, pardon, your voice is not clear.
Rubberized concrete. You are talking about the rubberized concrete.
Yeah, rubberized concrete. Yeah.
Yeah. Is it being used?
It is.
Is it used till now?
Sir, basically by using this waste rubber tire products means by products, that is the rubber ash and this rubber fibers, we utilize in the paver block, and as well as in the CTI, means in our college, in my college, I have casted a around 10-meter segment of the rigid pavement, means concrete pavement of around 200 thickness, and normal traffic is going from that is the basically normal cars and other vehicles are passing through them, and around I have casted that segment in 2018, and up to this there is no widen cracks or like that, and I have also done the paver block by using the rubber ash concrete, and I
How
have
long
also
it is being
filed.
used? How long it is being used?
Sir, basically I have developed these products in concrete pavement. I have casted in the 2018 around May or June, so takes around 2.5 years, and normal traffic, not I can't say that there is heavy traffic, because it is the college road. So this heavy vehicles are not permitted in the college, but normal routine traffic, that is the our normal vehicles, car and other vehicles, whatever loading tempo in some cases. So the performance is, we can say that after 2.5 years, there is no major cracks, even no hair cracks are visible. At the initial inception, whatever cracks was there, they are remain same. There is no much more means detrimental effects on the that type of pavement. And I have also developed this concrete paver block, dumbbell shape typed, but that was not means we cannot say that that was produced or manufactured at large scale. We have only simply manufactured in the lab.
Okay, thank you.
Okay, sir. Thank you.
गुप्ता साहब, आपका स्क्रीन शेयर हो रहा है, उसको स्टॉप करना होगा सर.
Okay, sir. Okay. Thank you, sir. Thank you.
Just a minute. Narayanan sir also has joined. He is our expert from Reliance Industries.
Namaskar, sir.
Namaskar, sir. Narayanan sir, this session was on stone processing dust in concrete as well as in rubber ash in concrete. If you wish to add your expert views in that.
Sir, I have only one point, which the rubber crumbs which are being used in concrete can develop self-healing concrete. This research paper has been published by the University of British Columbia, headed by my professor, Dr. Nemi Bantia. You may refer in the Google, so you will get an excellent article as well as a study which has been done in Canada, British Canada. So you can get a fairly good idea about self-healing concrete, where the cracks can be healed by using these rubber crumbs, shredded rubber tires and crumbs. So it's actually a very good, I just wanted to add that, sir. Thank you.
So definitely, I will refer that article definitely. But basically, my this byproduct was different from the this crumb rubber. Basically, I have used this rubber ash. That was the byproduct of at the time of pyrolysis technique. Uh, Basically, they used to extract the oil and steel fibers from the waste of a tire. So at that time, this rubber ash was produced, and at the time of mechanical grinding, normal mechanical grinding. In the case of the waste rubber crump, basically they use the different technique, and they crush the waste rubber into the to make the crump rubber, means in the predefined size, or use the sieve. But in our case, I do not use any type of sieve, so that whatever product available in the industry or in the market at the time of mechanical grinding, basically at the time of this we can say that the retiring, that is, so at the time of that, this waste rubber fibers was generated. So definitely I will refer that article, and I will use to make the self-healing concrete, and definitely that is a new research area for me. So I will suggest one or two my research scholars to take that topic, and they can further study the, or goes for the further study. Thank you, sir. Thank you for your kind
thank you,
suggestion.
Professor Trilok. Thank you,
Thank
Professor.
you. Thank you, sir. Thank you.
So if there are no further questions, there's one, I think you have already answered what is the effect of rubberized concrete on the shrinkage, I think.
Yes, sir.
And another question is, can we use steel waste as fiber? Maybe Dr. Narayanan may add to it.
Sir, can you repeat that question? Steel fibers, is it, in concrete?
Can we use steel waste as a fiber?
It's a good question, sir. It's a very good question. But the question is, since fibers are very, very important for concrete, because it develops a lot of tensile resistances as well as strain, it increases the strain hardening capacity. But the use of waste steel as fibers is a very big question mark, because there are excellent manufacturers of steel fibers in the country as well as abroad. But the use of waste, you will have to be very careful in use of waste, because number one is the corrosion, which is extremely critical. And number two is the aspect ratio of the material. So you'll have to be very careful about employing a good aspect ratio for the fiber. And then proper concreting practices also, because steel fibers are very difficult to handle, especially when it becomes balling effect will come, bunching of fiber. So you'll have to have an excellent glue to ensure that as soon as water touches the steel fibers, they get separated and they become independent fibers and orient itself. So that is my only worry.
Exactly, sir. Exactly. I remember one question asked with me in '95 when I presented first time SIFCON in an international conference organized by Osmania University in Hyderabad. So one participant asked this only, whether the SIFCON fails. SIFCON, of course, as you know, that employs steel fibers with high aspect ratio.
Yes,
so similar issues were asked on that day, because there were only two presentations on SIFCON, one by myself and another was Dr. Parmeswaran. You know Parmeswaran.
Dr. V.S. Parameswaran from Design Consultants, Chennai. Yes, sir.
Balu was with him. Balu Subramaniam, you know.
Yes, sir. Yes, sir.
So that team from SCRC Chennai and me was there, the second presenter. So a volley of questions came, because that was in '95. Lankard has developed in around early '90s, SIFCON. So not many people knew about it. Naman had only published stress strain characteristics of SIFCON in '93, '94 time.
Exactly.
So,
yes, sir. Correct.
So at that time, Indian people were not knowing this high aspect ratio steel fibers and all those things. So anyway, that's a good recall of the things when you talked about high aspect ratio and all these things.
Yes,
so
sir.
nice.
Wonderful. Wonderful. Thank you, sir.
And Ganesh Chaudhary ji started his business in India at that time with Tata Steel. Then now he's of course a big man in, of course, Beckett. You know Ganesh Chaudhary ji.
Yes, yes, yes. Actually, he started on his own. He has left Beckett. He was in the United States for 3 years in Beckett in US in North America, and then he resigned last year, and he's put up an industrial flooring company on his own. He's the president of the Indian Concrete Institute Western chapter.
Yes. He has been in. I had been in touch in those years with him.
Sir. Wonderful.
So of course, Beckett produces fantastic fibers. So I have used, and so many people all over the globe knows Beckett, Dramix fibers, and all those things.
Absolutely, sir. Correct.
So with this note, I thank on my behalf and Rajasthan Technical University behalf to my extend warm thanks to Dr. Trilok Gupta ji, CTA Udaipur, for sparing time today and enlightening us with his very good research work on the stone processing dust in concrete, its durability, its mechanical properties. The embodied energy concept is still not developed in Indian research area. I wish to add one thing, Dr. Gupta ji.
Thank you, sir.
First PhD in India with embodied energy concept was submitted by Professor Chani, Architecture Department faculty of IIT Roorkee. Among the reviewers, one reviewer rejected, what is this concept? That was in 2004 something. And then we contested, rather my supervisor and his supervisor is same, Professor S.K. Kaushik ji. So he contested, he chose to contest and sent to another supervisor. So another supervisor gave him A grade. That was the confidence level of my supervisor and Dr. Chani. So embodied energy concept was new, at least in 2004. Now, of course, it is coming up in the building materials as a good context. So I thank you so much for enlightening us, our participants, with that concept as well, embodied energy concept. I am very grateful to you, and thank you so much, Gupta sir.
Thank you, sir. Thank you.
See you sometimes.
Thank you. Okay, sir. Thank you.
Thank you,
sir. Okay.
I have just talked with Dr. Pateria sir. He was in some meeting, so he's joining us shortly. In the meantime, I request Dr. Hegde ji, who is here, if he wish to add something in the discussion which is going on since morning. Dr. Hegde ji is with us, if he wish to add something. Any participant, if wish to add their own experiences, because we have participants from various states of India. So if any participant wish to add his own research work or share his research experiences with us, they are welcome. Okay, I will just present Dr. I think I am displaying some introduction of today's speaker, Dr. I.K. Pateria ji. He is an accomplished and competent civil engineering professional with about 33 years experience in administration, project management, research, academics, and technical education. He is currently the Director, Technical, National Rural Roads Development Agency. He has been a professor in civil engineering at Government College of Engineering, Aurangabad, and he has presented his research works in various national and international conferences. He had his contributions in the preparation of draft of guidelines on new technology initiatives in rural roads under Pradhan Mantri Gramin Sadak Yojana. He has represented India in Research Committee of Asia Community Access Projects, and he has also worked as member of Research Council of Scientific and Industrial Research, CRRI, for the period of 3 years. So definitely his forefront. He is in forefront of the implementing agency in the country for the new technologies in the road construction, particularly in low volume roads. So I think Dr. Narayanan joined only to listen him, and we welcome Dr. Narayanan to spare time to join us.
Yes, Professor. Actually, not only to for Dr. I.K. Patria's lecture, but I also wanted to gain a lot of knowledge, because sometimes what happens is during this Corona crisis, we are looking forward to such educative webinars,
Yes.
which will increase our knowledge levels in various other domains, because civil engineering is like an ocean. So it's very difficult to master any subject in civil engineering, especially with new materials, new technologies coming every day. We
Yes.
need to gear up for that. So that is one thing. And I always admire Dr. I.K. Patria's presentations, actually. So I've been a long association. In fact, a lot of times listening to him in various seminars, which made me interested to get into waste plastics, because he was one of the legends who had professed the use of waste plastics in roads, because he wanted to address durability, because actually roads are the most vulnerable application areas for India, actually, because you have different types of climates, different weather conditions, different rainfall seasons, and what happens is most of these roads are subjected to such kinds of vagaries of the environment. It's
Yes, sir.
extremely difficult for us to make all roads in India as concrete roads, because it's extremely difficult, because it's very, very expensive. Initial cost is very high. So that is
Yes.
the reason why we need to safeguard our techniques and technologies with respect to bitumen road construction. So the advent of new materials and new technologies, especially the super paver technology, which has come in now, the laser screed, the automatic laser screeds, and then the various curing membranes and techniques which have all come in concrete road laying has become very important for the country. And you can actually make 1 kilometer road in one day. So, which was not possible 15, 20 years back when we started. And I started my engineering, we could hardly do 15 meters, 20 meters per day of road construction. So, this is a very good concept, as well as the bitumen itself. There's a lot of development which is happening with respect to bitumen. And the quality of bitumen is completely changed from what it was before. And then the quality of construction actually has deteriorated in the country. So with respect to all that, new technologies and new materials, basically, especially the rubber crumbs, which are getting into practice nowadays in road construction itself. And I recollect our union minister talked a few months back in a conference, in a road conference. He was actually very, very critical about the construction of roads in India. So these new technologies and the new materials which this webinar is organized, has become a very rich learning experience personally for me, which I can carry and tell people. So this is the reason why I thought I will attend all the 5 days in spite of some tough work which is happening in Reliance Industries.
So it is so nice of you, and good learning from you about your experiences, sharing, and definitely, sir. I wish to add, because I have been handling the technical proposal scrutiny at my university for PMGSY roads since last few years. So we have been noticing that the state technical agency, we have been given the task of state technical agency, even if the executive engineer or superintending engineer takes scrutinized proposals to NRDA, or this technical director is Dr. Pateria. So his team scrutinizes then again, and many times advises us that you have missed this point, you have missed that big point. So it is good that the quality of Pradhan Mantri Gramin Sadak Yojana's works has improved over his leadership. So I welcome Dr. Pateria ji, who has just joined us. Sir, you are welcome in this session. We are not getting your voice, sir.
Thank you very much. Thank you.
Our resource persons of other sessions. One is Dr. K.R. Narayanan sir from Reliance Industry. Another is Dr. S.B. Hegde ji from Udaipur Cement Works. They have joined this session mainly to listen you. Sir, they have been, we all have been very much aware of your leadership works at PMGSY roads. And I invite you on behalf of Rajasthan Technical University Kota for a session on low volume roads. Dr.
Thank
Pateria.
you. You need to give me rights for presentation. I'll just try. If it works, it is fine.
So it is inbuilt, sir. You may kindly present now. You may.
Yes.
Yes, sir.
And then a window.
Yes, sir. Yes, sir.
And then the presentation.
Yes, sir.
Okay. I hope it is there now on the screen.
Yet not, but it may come in a few seconds. Till now, it has not come, sir.
Let me. It is showing. It is saying you must grant permission in order to screen share.
ऐसा तो नहीं है सर. एक मिनट, ऐसा तो नहीं है सर. Everybody has been presenting. It is not like that, sir. होना तो नहीं चाहिए. Let me check. No, it's not. I have not changed any settings.
Then where is the problem?
Share screen is enabled, sir. I have checked the settings. Sir, you are able to see that PPT in the window, sir. So it's still showing some, still asking for the permission or what? सर आपकी आवाज नहीं आ रही है. एक मैं आपको अनम्यूट करता हूँ. कोई ऐसा इशू तो नहीं होना चाहिए। सर आपकी आवाज नहीं आ रही, आप अनम्यूटेड ही हैं, फिर भी आपकी आवाज नहीं आ रही। I do not know, some network issue. His network has lost. I will just talk to him. Or maybe in a couple of minutes he may join again. He has joined. Pateria sir, आपका एक दिक्कत तो रहा है. You may kindly present now. Try present now, sir. He's trying last time, otherwise he will mail me and I will then present, I will open the PPT file on his behalf. Sometimes the issues come in this online platform. Anyway, these are part and parcel of I think I will request Pateria sir to mail me the presentation. I will open the PPT file at my end. Pateria sir is requested, but I think he has his network is posing some problem. I will request him. I have requested him to mail me. The participants are requested to bear with us. This hiccups sometimes occur. Kindly be patient and bear with us. So he has sent me the mail. The mails, the PPT size is long, so that's why it is taking time. He will be joining just now. Yes, sir. I think Dr. Pateria ji has joined with Director CQC name. Welcome again, sir. As soon as I get the mail, I will just.
Yes. It is actually. I've just now sent the mail.
Yes, sir. Yes, sir.
I'm once again trying to make if it permits.
Sir.
No, it is not.
In the meantime, if you wish, may kindly give an overview of the works at your NRIDA or PMGSY, sir, to the participants. It seems there is some issue at his end. His connection again lost, and I was still yet to receive the mail. Some issue at his end on the network issue seems. Pateria, sir, I am still to get the mail, sir. I do not know where is it, why it is taking so much time, sir. Maybe large file or whatsoever. So I think participants are now able to see the presentation of Dr. Pateria ji's being displayed from my side. I request Dr. Pateria sir to kindly take control of the mic. I am muting myself, sir. Sir, the PPT is visible, sir?
Yes, it is visible to me.
Yes, sir. Then it is visible to all the participants. May kindly consider to direct me.
You can start with the presentation. Now the screen has moved out. I don't know where is the issue. Whether others are able to see. Hello.
हाँ, कोई पार्टिसिपेंट अनम्यूट करके बता दें, आप लोगों को स्क्रीन दिख रहा है क्या?
Yes, sir, it is visible.
Yes, sir.
But for me, it is not. Now I am not getting the screen. I am perhaps getting your screen, the entire screen, not the presentation part. Let me join again.
Sir, you have joined again, sir. Are you able to see the screen?
No, I am not able to see the screen. I don't know what is happening.
Uh,
Now I am able to see the screen.
sir. So should I?
No,
yes.
It has moved out once again.
First slide, it is not visible to you, sir.
One second. Yes, now it is visible.
Yes, sir.
So you will be moving the slides now.
Yes, sir. Yes, sir.
Okay, so move to, I'll just say next, please.
Yes, sir.
Yes, next, please.
This is status of road network.
Yes, but now right now it is not there on the screen. Okay, what I will do, I will start presentation from my side. You can accordingly move the slides.
Yes, sir. Yes, sir.
I have a copy of it because otherwise we are losing time and the participants are just wasting their time.
Yes, sir. Yes, sir.
Right?
Yes. Yes, sir.
I may not be visible to the participants, but I hope my voice is clear. Any participant, please? I'm audible?
Yeah, you are loud and clear, sir. Please proceed.
Okay. So, Agrawal sir, what you will have to do, I will be just moving the slides on my screen and you will be moving the slides on presentation screen.
Yes, sir. Yes, sir.
So first is the use of Flyash. Now I am going to status of road network because we have lost a lot of time. So I will be moving a little faster. And then I will be talking also and you can move the slides accordingly.
Sir.
Fine?
Yes, sir.
In case there is any mismatch, you can just tell me that there is something hidden or there is some mismatch.
Yes, sir.
Okay. Very good afternoon to all the participants. I'll start with the status of road network in India. In fact, it has always been a big problem that in India we still do not have any repository of the total road network in the country. There is no single agency which has a complete record of the entire road network in the country. Actually speaking, this responsibility lies with the Ministry of Road Transport and Highways. However, in spite of repeatedly, they are following up with various agencies, because there are n number of agencies who are constructing roads. There is Ministry of Road Transport and Highways who are constructing the national highways. There is National Highway Authority of India. There are State Public Works Department. There are State Rural Works Department or Rural Engineering Department or Rural Roads Department. In addition to that, in urban areas, there are many urban agencies, municipal corporations. So overall, there are n number of agencies who are working in this sector, and perhaps because of that, the entire road network complete details, I will say, even on GIS, are not available in the country as on date. The Ministry of Road Transport and Highways publishes annual record of the road network as statistics. So road statistics in India. This report is published every year, and the data which I am showing on the screen right now is of 2017. Why I am showing this data? Because this is the authentic record as per the Ministry of Road Transport and Highways. Here you can see the road network in India is 51 lakhs kilometers. National highways are 1 lakh. As actually on the next slide, you will find a little different data, because as on date, it is much different from what has come on the screen. State highways around 3.5%, which is 1.7 lakh kilometers. Major district roads 5,61,940. Rural roads 42,54,000 kilometers, including the project roads. So roughly this shows, it is the government publication which shows around 83% of the roads, including project roads, are the rural roads. That is what the whole purpose of showing this slide. Next, please. In the second slide, now you can see here, this shows 56 lakhs 3,293. This is as on date record from the same Ministry of Road Transport and Highways, NHAI website, etc. So roughly 5 lakh kilometers data difference is straightway there. There are variety of regions. We need not go into the details. Our focus point is as far as low volume roads are concerned, which are mostly looked into by rural works departments, PWDs, and Panchayati Raj institutions in different states. Here it comes to around 70%. I have kept here the project roads separately, which if added around 6% becomes 76. So we can say in nutshell that rural roads are not less than 70% of the overall road network of the country. Actually speaking, in terms of length, it is more than 70%, but in terms of volume which they carry, it is very small. 40% of the commercial traffic is normally carried by the national highways, which are only 1.8%. And that is why for last 10-15 years, you must have seen huge schemes, huge number of schemes, or tremendous investment is being made in development of national highways, so that this can be made at least 4 to 5%, and the load of traffic can be substantially reduced on the existing highways. Now moving to our today's discussion, this is the general section of the rural roads. I am working with Ministry of Rural Development as Director Projects as of now. Earlier, I have served for a full term of around 7-8 years as Director Technical. As on date, working as Director Project, I am responsible for quality assurance systems, trainings, human resources development, and R&D component under the Pradhan Mantri Gram Sadak Yojana. So this is the standard section which is being used commonly in most of the rural roads. Here you can see we have a thin embankment of around 300 millimeters, 300 millimeters subgrade. Above that, we have around 150 millimeter granular subbase, 2 layers of WBM, and a thin bituminous premix carpet surface with seal coat. This is the general cross section. Both sides there are shoulders which are around 1.7 1.85 meter wide. The overall road top width is 7.5 meter in general. Many times it is 6 meters, and even now we are constructing a couple of intermediate lanes. So there the overall width at top will be around 9.5 meters. The purpose of showing this slide is that in rural roads, we are constructing the embankment, including the subgrade, which is not more than 600 millimeters in majority of the roads. The general impression in the minds of our qualified engineers is that when we have a thin embankment and subgrade less than 600 millimeters, how fly ash can be used in construction of rural roads. So that is what we will be discussing in the upcoming slides, that even with this kind of the thin sections, or even when we have this kind of the thin subgrade and embankment, we can make use of fly ash, and a couple of roads have been already built in various components. If there is a will, we can definitely do it. So actually speaking, in embankment, in subgrade, in sub-base course, in some of the base courses, in shoulders, and even in bituminous layers, the not exactly the fly ash, but the pond ash, which is a coarser part of the fly ash, can be used in shoulders, etc. So we will be now taking in detail a talk as to how the fly ash can be used in various sections. Now, I hope fly ash has been already covered in some other lectures, so I will be moving a little fast. Just the definition. When pulverized coal is burnt in furnace of the power stations, finer part of the ash gets carried along with flue gases and is collected by using either electrostatic precipitator or cyclone precipitator, which is called as fly ash. So the ash which is deposited on these precipitators, collected through precipitators, that is fly ash, remaining ash sinters and falls down at the bottom of the furnace, so known as bottom ash, which is little, the particle size of bottom ash will be little higher than that of the fly ash. And when fly ash and bottom ash are mixed and disposed in the form of water slurry to ash ponds, it is called as pond ash. Because the volume of this fly ash, bottom ash and pond ash taken together is huge. Normally, there are ash ponds created at every thermal power stations, and wherever the coal is being burnt for heating purposes. So because of the quantities, they normally create pond ash where this material is deposited. It has several desirable characteristics such as lightweight, ease of compaction, faster rate of consolidation, better drainage. For construction of embankments over weak subsoil, fly ash could be a very preferred kind of the material. Now, before we move further, what efforts we have made in order to promote the use of fly ash in construction of PMGSY low volume roads. In fact, in 2013, we published detailed guidelines for use of various technologies. Really speaking, I do not consider fly ash to be a new technology. However, because this has not become still a very common material which is being used by most of the road agencies, that is why we have still kept it under the subcategory of new technology. So when fly ash is being used in some or the other form, the road is sanctioned as a road of new technology initiative. So what we did in this case, in fact, the IRC guidelines provides for that there should be a minimum cover of 50 centimeter on fly ash layer. So in our new technology guidelines, as I said in the beginning, that our total embankment, including subgrade thickness, is hardly 60 centimeter. And we have to provide a cover of 50 centimeter to fly ash layer. That means only 10 centimeter embankment can be made with fly ash. So just to avoid this, what we did, we discussed with couple of stakeholders, fly ash producers, other scientists working in CRRI and various other agencies, and finally took a decision that out of 60 centimeter, we will be making 30 centimeter embankment with fly ash, and the requirement of all-round cover can be reduced to 30 centimeter only. So we issued these guidelines. Then Government of India has also issued guidelines in general that within 100 kilometer of thermal power station, the use of fly ash in road construction is mandatory. We got this also revised in 2016 after a lot of discussion with Niti Aayog, which is keeping a follow-up with all agencies for utilization of all kind of waste materials. So then Ministry of Environment and Forest has issued these a separate government resolution, which clearly indicates that for rural roads, especially being constructed under Pradhan Mantri Gram Sadak Yojana, the thermal power plants, from thermal power plants up to 300 kilometers, the transportation is to be done by the producers, and it is to be supplied free of cost right at the place of construction of road. So this kind of the administrative changes have been made, and at couple of places we could get success after this administrative decision was taken, because still the issues of who will transport, whether to actually speaking, the guidelines are absolutely clear that the plant producer has to give it, but there are administrative issues because these plants are mostly the government operated plants, so always there are various types of the issues which come in when any guidelines are issued. So fly ash can be used for stabilization of clay soils in addition to construction of the embankments and subgrade. To facilitate the availability of fly ash and pond ash, a map showing the locations of thermal power plants has also been provided with the new initiative guidelines. I'm just flashing on the screen this map, which indicates the location of all thermal power plants in the country. I hope I'm visible and audible. The screen is visible. Hello.
Sir, you are audible to me. I think any participant may confirm if it is visible. Any participant can unmute himself or herself and confirm whether the slides are visible.
Yes, sir, it is visible.
So right now on the screen, there is a map which shows the locations of various thermal power plants in the country. Now, what we have done using this map, which was prepared basically by this Central Electricity Commission, we have requested them to provide the geo coordinates of all these power plants. We have requested each of the plant operators to provide us the general characteristics of the fly ash, pond ash, whatever is available. And we have also requested them to provide the contact details of the people who will be handling the supply of the fly ash or pond ash to the concerned agencies who are constructing the roads. Whosoever has provided, we have put it on our website, pmgsy.nic.in. We have got a now we have got a complete GIS database. So there we have provided the locations of these plants, and from each of the plants, in order to check whether I am within 300 kilometers or whether I am in 100 kilometers, transportation from which of the plant will be easier and will cost less, we have provided a facility on that GIS platform that the user can click and draw a circle of 100 kilometers, 200 kilometers, and 300 kilometers, so that he will come to know from which plant he should get the supply. So with this, couple of agencies have come forward, and now they have started use of the fly ash. Design and construction of fly ash embankments. In general, these are the design considerations. Fly ash embankments is similar to, the design is similar to that of the soil embankments. Fly ash embankments of height up to 3 meters can be constructed adopting a side slope of 1:1.5. Regardless of height of embankments, fly ash embankments should always be constructed with soil cover. The focal point is that wherever we are using the fly ash in layers, we have to keep a minimum all-round cover of 30 centimeter. That is on sides as well as on top. Special emphasis is required with respect to provision of earth cover for fly ash embankments. The embankment can be designed as a composite structure with fly ash in the core and earth cover on the sides. Means we can have a complete core of fly ash compacted in layers, and then on all sides, on top as well as on sides, we can have a cover of 30 centimeter. A factor of safety for embankments constructed using fly ash should not be less than 1.5 under normal serviceability conditions, and should not be less than 1 when checked for worse combination under seismic and saturated conditions. So this is additional factor of safety. Typical cross section of fly ash embankment with and without intermediate soil layers are shown in the subsequent slides, which are here. Now here you can see, in fact, this also shows 0.5 meter minimum cover, but later on we have changed it to 30 centimeter, 0.3 meter on each side. You can see both of the sketches. In one sketch, a complete core of fly ash is there, that is in figure 9.3, bottom one, and on the top, there are 3 layers which may be of any thickness, and in between these layers, there is a soil cover. That soil cover may be designed and decided accordingly, but on all sides, there has to be a minimum cover of 30 centimeter. Now, this is actually speaking my own sketch, which is not complete in all respects. You can see the previous slide as well. Here you are seeing 2 alternate options for use of fly ash in embankment and subgrade. That is a complete core or fly ash being used in layers. So this is above the ground level. The use of fly ash in these 2 sketches is above the ground layer. But below this here, or below this, even below the ground level, I have just drawn a reverse trench. Actually speaking, now even the muram and good quality soil is becoming a prized commodity. It has been classified as minor mineral. So there are huge issues for large projects. Getting the soil is becoming difficult because now the farmers, they are not allowing to take it from their fields. The government lands are reducing, and transportation costs, if you have to bring it from long distances, the transportation cost makes the project unviable. At the other end, disposal of fly ash is also another big issue. So what has been thought of after discussion with the Ministry of Environment and Forest and CRRI, that a reverse trench can be excavated along the alignment where a new road is to be constructed. If this soil is good, if the existing ground soil is good, maybe with CBR of 4-5% or 3-4%, a reverse trench of 30 centimeter or equal volume as the embankment is to be constructed can be excavated just below the alignment, and the soil can be kept on both the sides. The fly ash can be filled in this trench in layers, 1, 2, 3 layers. And then over this, the embankment can be constructed as usual. So this will increase the consumption of fly ash in construction of roads, because once a road is constructed, that area of land is blocked forever. You cannot use it for dumping the fly ash or any kind of the waste material. However, at the time of initial construction, you have the opportunity of using it. So what will happen? Here you will fill up this trench with fly ash. Substantial volume will be consumed. And on the top of it also, you will have a 30-35 centimeter high embankment, either as a core or in layers, constructed with fly ash. And then the soil which has been taken from here can be used to provide the soil cover on top of that embankment and on the sides. So complete material has been utilized, and huge quantity of fly ash has also been consumed in making the fly ash. That means almost you are not required to bring the good quality soil from outside for making the subgrade. That is the whole purpose of doing this. Now here you can see the fly ash embankment is being compacted for construction of road. This is another picture from another area. These are some low cost agricultural equipments which are being used in construction of fly ash embankments or pond ash being used as a stabilization material. We can use the fly ash in various forms. We will be discussing in subsequent slides. One, we have already discussed that it can be laid in layers, alternate layers with intervening layers of good quality soil. Second, we can make the entire core of the embankment with fly ash. The third option is we mix it with soil. So for mixing purpose, this kind of the low cost agricultural devices are being used, because if you bring a very high cost stabilizing machine, the overall cost of the project may not remain affordable, particularly for the case of rural roads. And mixing with the help of the harrow disc or rotavator, which are being shown in this slide, is substantially good and very economical. So either pond ash or because pond ash is granular in nature, mixing it with very poor quality soil improves the bearing capacity or the CBR value, which is in general a term used for design of the low volume roads. So mixing can be done with these agricultural equipments, which are now available in every village. And then the compaction can be done with the help of rollers. I will be showing the properties of the fly ash in the next slide. These are the general properties of the fly ash acceptable for embankment construction. All of you are familiar with various characteristics of the soil which is being used for construction of embankment, and these are almost in the same range, so not an issue. Only issue is it is light in weight. So for construction of the core, there is no issue. And otherwise, it can be mixed with the local soil to improve the characteristics of the local soil or to improve the CBR value. This here you can see, this is a slide which shows some of the publications of National Rural Road Development Agency, where I am working. And at the bottom, you can see rural roads construction using fly ash. In order to easily understand and do it without much of training, a small guide has been published on fly ash, do it yourself rural road construction using fly ash. This is our own publication available on our website and has been prepared in consultation with many agencies working in fly ash. And I hope it was published somewhere in 2015 or so. A colorful small booklet, maybe of say around 10-15 pages, available on the website for free download by anyone who is working in this sector or even not, because it is in order to promote the use of fly ash. These are the steps which are commonly followed in construction of fly ash embankment: clearing and grubbing, stripping and storing of topsoil, because that is normally good for from agricultural point of view. So can be either can be given to the farmers, or if it is a hard soil, it can be reused after the embankment of fly ash is construction for using it as a cover. Then setting out, marking the center line of road, compacting the ground supporting embankment with the help of rollers. In handling of fly ash, there is because it is very light in weight, and if it is transported in open dumpers, it will be carried by normally it may be carried by the air or by the wind. So it is expected that while handling the fly ash or transporting the fly ash, it should be carried in, it should be covered. Then spreading and compaction should be done. I'm just skipping the slides 1 or 2. Spreading and compaction. The fill material is preferably spread by mechanical means and compacted with the help of vibratory or static rollers. Now, vibratory rollers are also very common, which gives better compaction of fly ash. Each layer of fly ash shall be thoroughly compacted to specified density, which is almost 98 to 99% of the laboratory density. And then finishing operations, which includes work of shaping and dressing of shoulders, verges, roads, beds, and side slope to confirm alignment, levels, cross sections, and other dimensions of the overall embankment size. A lime fly ash mix can also be used. A mixture of fly ash and soil when stabilized using lime is called lime fly ash stabilized soil, which can be used for constructing sub-base and base course for rural roads. Many of the people sitting in the audience might have seen the lime constructed roads hundreds of years old, or lime constructed buildings hundreds of years old. So lime and fly ash mixed together can be used for construction of the base course or sub-base course. This is part of our book of specifications. However, because of non-availability of pure lime or appropriate quality of the lime at various places, this is rarely being used. Lime fly ash combination is rarely being used. Lime fly ash bound macadam. This is a very good specification, but again, the issue is availability of lime and the technology of mixing it with the aggregates, so that in place of water bound macadam, lime fly ash bound macadam can be done. But this is also rarely being used, only because of the issue of availability of this lime, good quality lime. Now coming to lime fly ash concrete. Lime fly ash concrete is resistant to softening under water action and can serve as a good working platform on soft foundations. Wherever we have poor soil or very soft foundations, there it can be used as a good alternative. A lesser thickness, the thickness of WBM can be reduced because we are providing lime fly ash concrete as a bed at the bottom. It is suitable for heavy rainfall areas, black cotton soil areas, and places where good quality aggregates are not easily available. The specification is there, but the problem is in those areas which are having very high rainfall, such as northeastern states of our country, but they do not have availability of fly ash in that area. Now the first plant has come in Assam, and beyond Assam, there are no thermal power plants in 7-8 states in Northeast. So that is why use of this specification has also been very limited. Dry lean fly ash concrete for base course. We normally use DLC below the concrete pavement. So that can be replaced as DLFC. Part of the cement can be replaced with fly ash. And that is why we call, so that is what we call it as dry lean fly ash concrete, which is almost similar to DLC. Then we also can have cement stabilized fly ash. This can consumes substantial quantity of fly ash, which consists of laying and compacting a subbase or base course of fly ash treated with cement or prepared subgrade on treated with cement on prepared subgrade. This technique can be adopted for improvement of poor subgrade also. In order to promote this technology and to consume substantial quantities of fly ash and pond ash, we have undertaken a project with CRRI around 3-4 years back, which has been completed in 2018, as to whether the subbase can be constructed or base course can be constructed with fly ash, which can be stabilized with cement. And a trial section within the campus of CRRI was constructed. The results were very encouraging. We have, based on the outcome of that small research project, which took almost 3 years, we have sanctioned a couple of roads in the states of Bihar, and I hope the other state participating was Madhya Pradesh. So 1 or 2 roads have been sanctioned using fly ash alone as a base course. So in place of granular sub-base course, which is popularly known as GSB, the sub-base course is being constructed with fly ash, which is being stabilized with around 5 to 6% cement, depending on the quality of the fly ash. Bottom ash or coarse type of fly ash can be used in place of granular sub-base material, provided they have CBR more than 15%. As I said in the beginning, that this bottom ash and pond ash. Bottom ash is normally granular, and this pond ash, because finer materials are carried by the flowing water under the jet of water, and this pond ash is coarser in size. So it can be used for construction of shoulders or for mixing in the GSB material. And if it has substantial granular material in it, then it can be directly used as a granular sub-base course without any alteration or without any stabilization. Otherwise, it is mixed with local soil or local muram, so that we get a CBR of more than 15 or 20%, which is the bare minimum requirement. Now, in the next slide, I am showing the MORD specifications for rural roads. In fact, till year 2000, before start of the Pradhan Mantri Gram Sadak Yojana, most of the rural roads were being designed based on thumb rules or following the same design principles which are being used for design of higher order roads such as state highways or major district roads or whatever. So it is after the Pradhan Mantri Gram Sadak Yojana was started in 2000, in the year 2000, the first rural roads manual was published in 2002, and specifications of some of the items were included in that rural roads manual, which were different from that of the higher order roads. Later on in the year 2004, a separate specifications for rural roads was published on the request of Ministry of Rural Development by Indian Roads Congress, and in the name specifications for rural roads. So this was the first ever publication which included the specifications of fly ash also for construction of rural roads. This has been further revised in the year 2014, which you are seeing on your screen on the right side, known as the Red Book. Ministry of Road Transport and Highways has a similar specification published by IRC, and that is known as Orange Book. So that is MORTH specifications for roads in the country. And now this has been brought out separately by IRC and revised in 2014 as MORD specifications, which provides all specifications of materials and workmanship for low volume rural roads. Revised edition 2014. On the left side of the screen on this slide, you are seeing the earlier version of this book, that is red in color. Here you are seeing the earlier version. So this consists of specifications of all those items which we have discussed now. That how to make use of fly ash, what are the properties, requirements of fly ash when we are using it in embankment, when we are using it in layers, when we are using it as a core, when we are using fly ash in granular subbase layers or bottom ash in granular subbase layers, when we are using fly ash or bottom ash or pond ash in shoulders. So when we are using it in cement concrete pavements, when we are using it as a lime fly ash combination, all these specifications have been included in this book. And these are given in some of these slides. I will not be talking on them. I will be quickly moving. I will request Professor Agrawal to move the slides one by one a little quickly. So this we have already discussed. I am just skipping it. Here is a comparison of the fly ash which is available in our country and the fly ash in US. You can have a direct comparison of these two, and our specifications are mostly based on the Indian fly ash. MORD specifications are mostly based on the Indian fly ash. Normally, a question is raised by most of the engineers when they are not very comfortable with the use of fly ash, that there may be some leaching from the fly ash or any of the waste materials or any of the new materials. Here, this comparison shows that leaching in case of Indian fly ash is much lower than what is happening in case of fly ash being produced in US. So rate of leaching is lower, or I will say that leaching is almost not a problem in case of fly ash. Most of the thermal power stations have got it tested at various testing centers, and this should not be a point of worry if fly ash is to be used. I will be just moving fast. This is section 306, which provides all these specifications for fly ash embankment construction in rural roads. This is again continuation of the same. This is typical cross section of fly ash road embankment as per IRC SP 58. There is a separate IRC specification over and above our MORD specifications, which covers construction of fly ash road embankments. It is IRC SP 58 being displayed on your screen. This covers construction of road embankments of all types, not very specific to rural roads. So out of this specification only, we have drafted the specifications for MORD book of specifications. So these are the guidelines for use of fly ash in road embankments. I am just skipping it. The same thing out of SP 58. Now these are the engineering properties of fly ash and soil being compared. You can see that in most of the cases, the fly ash is almost having the similar properties as that of the soil. Maybe silt or maybe clay. Only thing is the density is lower because it is light in weight. And that is why, as I said, that in order to make use of it in the shoulders or in other layers other than embankment, normally it is mixed with some other local material, so that the density is also increased and satisfies the bare minimum requirement as per the specifications. The rest of the properties are not much different from that of the soil or from that of the silt and sand. And even if they are different, they are definitely on positive side. So not. These are the results of some of the fly ash from various thermal power stations where it has been used in construction of rural roads. I'm just showing you one by one. This is from Kehelgaon in Bihar, where this project was taken. This is again the same units used for mixing. These are the characteristics from, yes, this table is based on that CRRI project, where Flyash was used for compaction, for stabilization with cement. Here you can see 65% pond ash, 29% soil, and 6% of cement was used. The 7 days UCS was 1.35 MPa, and 28 days UCS was 2.6 MPa. So this satisfies our requirement of sub-base course, and that is why based on this we have sanctioned a couple of projects, though we later on advise the states that the pond ash component may be reduced a little bit because it is the first project. So maybe reduced by say 10 to 15%, and some local aggregates may be added along with the soil to further improve the UCS for sub-base course. This I am skipping a couple of slides. Flyash for road pavement construction. This also a stabilization part we have discussed. This is a very important figure which will make the things more clear. Typical cross section of rural road, conventional section, and using Flyash. What happens normally here? This is our muram is used, or granular material is used as a sub-base course. Below that is subgrade. So below subgrade, there is embankment. So embankment and subgrade together can be constructed using Flyash, or soil can be used to construct the subgrade, and the embankment can be constructed with Flyash. Over that, we normally have this muram or GSB sub-base course, which can be replaced in order to promote the use of pond ash or Flyash. We can make it. That is why I have drawn these together. Mechanically stabilized pond ash as a sub-base course. Over that, the cement stabilized ash, cement stabilized pond ash, and cement stabilized Flyash, one layer, which is equivalent to one layer of WBM. So where the stone material is to be transported from long distances and Flyash is easily available, Flyash can be stabilized with cement and can be used even as a base course layer. Here you can see. And on the top of that, only one layer of WBM can be constructed, and then the premix carpeting can be done. The projects about which I was talking were based on this design. One or two projects near this Kehelgaon plant in Bihar, and one or two projects in Madhya Pradesh. These are some photographs just showing you for how it is done. Basically, these are old photographs which have been done with manual labor, but now it is almost out because now we have got sophisticated equipments available with every contractor. So just spreading the Flyash and then compacting it with rollers. Now everything is done mechanically. You can see some more photographs. These are the high cost stabilizing machines about which I was talking. So for large projects of highways, this kind of the stabilizing machines are being used rather than using the rotavator and harrow disc, etc. So I'm just skipping this. Plain cement concrete, all of you know that the Flyash the cement can be replaced with Flyash provided we are using ordinary Portland cement. If we are already using PPC, then probably this should not be done. And even if it is required to be done, even if somebody plans it to do it, it should be done under strict laboratory quality control. In the lab, first we should design how much cement further can be replaced in case of PPC. Normally it should not be. So after Flyash, the cement comes 270 kg 270 kg per cubic meter minimum, which is normally say around 350 kg per cubic meter to 425 kg per cubic meter. So how much, even in OPC, how much cement can be replaced, that is also to be decided in the laboratory trials, and then only it is to be permitted for execution. So these are the specifications available in the Red Book as well as in the Orange Book of Ministry of Road Transport and Highways. They are almost identical. Only thing is, in case of rural roads, we have further relaxed the limits, because the loading on rural roads are much lower than that of the higher order roads. Then coming to roller compacted concrete. This has not been used on a very large scale in India, but under PMGSY, we have tried to construct couple of roads using roller compacted concrete. And in one or two cases, even replacing the cement partly with the help of Flyash. So Flyash replacing cement to the extent of 25 to 30%. Of course, when OPC is being used. One such project of around 35 kilometers length is still going on in the state of Madhya Pradesh, where we are getting part of the Flyash from Pateria thermal power plant, which is now almost closed, but the S is still available from the pond S, from the S ponds. These are the same specifications of roller compacted concrete. This is what is required as aggregates in that concrete. Cement concrete blocks, there also to some extent the Flyash can replace the cement, but that again has to be done under strict quality control. This is the same figure, how the bottom S can be used or Flyash can be used, and then we have to take a soil cover of minimum 0.3 meter. Here you can see below the pavement layers, stabilized Flyash base has been put with 100 mm thickness. So the design which I have shown in the previous slide was used in this project also as a demonstration project. Now, as the organizers at the last moment asked me to talk something about the best plastic in construction of rural roads, I will be just taking 10 minutes talking on this. In fact, this waste plastic technology has been used under PMGSY on a very large scale. And I don't know whether the audience is aware that we have already constructed more than 15,000 kilometers of roads till now using waste plastic. This technology, in fact, was initiated by a person which you can see in the next slide. Here you can see Professor Vasudevan from Coimbatore. He is a professor of chemistry, and he started some work independently somewhere in 2002-2003, and till 2012-13, whatever roads were laid, they were within the university campus or within the institution's campus where he is working. At the same time, CRRI was also independently working on the use of waste plastic. And in 2010-11, they gave us tentative specifications for use of waste plastic in bituminous layers of roads. So we issued it to the state as it is, because we were not having much experience of use of the plastic in construction of bituminous layers. So whatever was provided by CRRI was sent to all the states, but barring a few projects on pilot basis, not much work was initiated. People were not taking much interest in adopting this technology. As I said that in 2013, we issued detailed guidelines on new technology initiative to all the states under PMGSY, wherein we mandated that every year whichever streets comes for sanction of the projects, they will have to bring minimum 15% of the total length with any one of the technology, either plastic or fly ash or coir or jute or any of the cement based stabilization technique or cold mix technology or whatever. So we listed n number of technologies and gave an option to the states that you can select any one of the technology or a combination of these technologies. But if you are coming with a proposal of 1500 kilometers in 1 year or in one batch, you will have to propose minimum 15% of it with any of the technology. So if you are coming up with 1000-kilometer proposal, 150 kilometer will have to be with any of the technologies. And this waste plastic technology being very simple and easy to execute, people immediately jumped over this technology. Said that most of the people or most of the states started coming up with the proposals of using waste plastic in rural roads. So what this waste plastic technology is, I'll just take 2-3 minutes in this IRC guideline was issued in 2013 on lot of initiation from Ministry of Rural Development, that we have huge quantities of waste plastic mostly being produced in the city areas, urban areas, but nobody is using it in construction of roads, or so the waste plastic is littering around the city areas, outside the city areas. So we proposed to IRC that detailed specifications in consultation with CRRI be brought out, and this was the publication which was finally out in 2013. There are two processes of using waste plastic in bituminous construction. One is dry process, where the plastic in dry shredded form is mixed with hot aggregates. There is another process known as wet process, where the plastic is heated and is mixed with bitumen. But that process has still not been approved by the Indian Roads Congress, so we are not using it. Now, what this is, because we were not having a perfect mechanism for mixing of the waste plastic with heated aggregates. So we started on a very rough mode or with a very rough technique. Here you can see this is an old bituminous plant, where this is conveyor belt. The aggregates are passing through this conveyor belt into this heating chamber. And there onwards, the next chamber is for mixing of, here the aggregates get heated because there is fire. So the temperature in this chamber is supposed to be around 175 to 200 degrees Celsius, because the aggregates are to be heated at 175 degrees Celsius. So this is Professor Vasudevan, who is having a temperature gun in his hand and it's trying to check the temperature of this heating chamber. This picture is from a mixing plant near Indore, where we had a workshop for all the PMGSY engineers in 2014. And after that, Madhya Pradesh is one of the states which has taken lead and has constructed more than 7,000 kilometers or maybe even around 10,000 kilometers of roads with waste plastic. So the process from where we started, from this conveyor belt, the aggregates are passed on to this chamber. So we initiated and said that on the conveyor belt itself, the plastic be sprayed, and along with aggregates, it will be taken into this chamber. It was just a beginning. We had no idea as to how to make it perfect. So this process was good enough. Though we regret that while doing this process or while going through this process, if the temperature in the first chamber is not maintained, part of the plastic gets burnt. and it produces a lot of harmful gases. So we have to be very careful that the plastic is not burnt, but the temperature is maintained to around 170 degrees Celsius or 175 degrees Celsius. And then in the next chamber, because the plastic and aggregate, so plastic is heated, aggregates are heated, they are going together. So the plastic covers the aggregate surface because it melts when it comes in contact with the heated aggregates. And then it goes to the next chamber where the heated bitumen is mixed with it. And this heated bitumen and plastic coated aggregates are mixed together so as to prepare the mix for laying the bituminous layers. But this is a raw process. So over a period of time, we realized that doing this is not good because we observed at a couple of locations that part of the plastic is burnt. There are gases being produced and smell is there in and around. So we thought that it is harmful and detrimental to the environment. So we just tried to search out some other alternative. And here is that. Here you can see this is threaded plastic. This is roadside plastic waste, which is to be cleaned, dried, and then there is a shredder, which is hardly costing say 1.5 to 2 lakhs rupees. It is electrically operated, in which this waste plastic collected from the roadsides is pushed on to convert it to this kind of 3 to 4 mm size pieces, shredded plastic. Then with couple of local jugaad kind of the people working in Punjab, we got this machine developed. So this machine is not for shredding the plastic, but it is plastic mixing machine. Here you can see this is similar to our this atta chakki. The waste plastic, shredded waste plastic is pushed into this hopper. From this hopper, it comes through this pipe. This pipe is insulated, and there is a fan or there is a motor behind it which pushes it into the pipe, and through this pipe the material, this pipe is inserted into this heating chamber of the previous, so it passes, the pipe passes through this chamber in which there is fire. So plastic is not affected with the fire, and then it goes to the next chamber where it falls from this, it falls from this pipe. Because the pipe is insulated, it is not affected with the heating process. So in the next chamber, there are aggregates which are coming from the conveyor belt and are heated in the first chamber, over which from this pipe the waste plastic falls. Plastic is not heated. Aggregates are heated to 175 degrees centigrade. When they come in contact, the plastic coats the surface of the aggregates and there is no burning of plastic. So now we have recommended that this kind of the device should be used for pushing the plastic into the mixing plant. Then next is, this is another model of the same machine. Here you can see after the mix comes out of that last chamber, this is being sprayed with the help of, it is transported with the help of dumpers, spread with the pavers, and this is the finished rod. Here you can see, so many roads have been built, and now it is very common. There is no new technology as such. This is a slide which was available because I was told today morning only, so I could not get from here and there, but this slide was readily on my desktop. This is almost you can say 2 years old data. So by that time around 13,000 kilometers have been already built, and that is why I said that almost 15,000 kilometers have been built by now, because every year we are constructing, say around last year, or you can say this 2020 was a big problem because of COVID, and in 2019 also we could not do much, but otherwise we are constructing almost 40,000 kilometers per annum. Now, what kind of plastic can be used and what kind of plastic cannot be used? So this IRC SP 98 2013 has brought out very clearly which are the grades of plastic which can be used. Reused plastic cannot be used. So black color polythene, we can make use of plastic bottles, we can make use of bottle caps, we can make use of all kind of plastic and polythene, which can be easily shredded and which can be easily melted. So there is a table given in SP 98 2013, which clearly specifies what kind of plastic should be used and which are the categories of plastic that should not be used. So anyone interested in this process should refer to IRC SP 98. And now the Ministry of Road Transport and Highways has also issued guidelines to most of their bigger projects that within 50 kilometers from the large cities, if there is a project going on, the use of waste plastic has been made mandatory. But this needs to be looked into very carefully. In 2019, IRC was trying to bring out a new publication of or a new edition of this IRC SP 98 2013, but that is still due because there is one issue on which the discussion is still going on. The issue is this 98 2013 version of IRC SP 98 says that when you are using plastic, the volume of plastic will be around the weight of plastic to be used in bituminous mix will be around 6 to 8% of the weight of bitumen. I repeat, the weight of plastic will be 6 to 8% of the weight of bitumen. And an equivalent quantity of bitumen can be reduced. So if you are adding 6% plastic, reduce the quantity of bitumen by 6%. Weight of bitumen by 6%. If you are using 8% plastic, reduce the weight of bitumen by 8%. Now the discussion was that reduction in the quantity of bitumen may not be appropriate, and that is why this IRC new volume is new edition of SP 98 is being thought of, but consensus could not be built still on that, though the council has also agreed, but still there were a lot of issues coming up from the user agencies, and that is why still it is due for publication. But I hope that maybe in next couple of months the updated version with whatever recommendation is made, that will come up, and this covers only the dry process of use of waste plastic. So I think from my side, I have tried to cover up both these things which were asked by the organizers. Thank you very much for patiently hearing. And if you have any questions, I will just try to answer from my side. Thank you.
Thank you very much, sir, for giving a patient, comprehensive presentation and updated knowledge to the participants. And I request participants, if there is any query, they may ask. Only a couple of queries because already we are late. Anyway, you are welcome to ask any queries, please.
Professor, can I ask a question?
Yes, sure. Sure.
Dr. Pateria Saab, again meeting you in a virtual conference is my pleasure. And
thank you.
Thank you very much, sir. Wonderful presentation. I always look forward to listening to your presentations wherever I go, wherever I get an opportunity. Doctor, the last part was the most interesting part, waste plastics in roads, because I handle that at the moment in Reliance Industries, apart from various other projects. So you are also aware that in 2019 December, we had a meeting at the IRC Council And at Delhi, we represented from the petrochemical side, the polymer side, on the recommendations of the appropriate plastics polymers to be used in roads. As such, the 2013 IRC SP98 code was not clearly defining, though it said plastic bottles and caps and things like that. But when we did a lot of practical projects, we found that these are all part of the rigid plastics. And then they were not melting because PET bottles were melting at around 250 degrees Celsius. So then what we did was we had provided the recommendations which was tabled in front of Shri I.K. Pandey, Dr. I.K. Pandey and Dr. R.K. Pandey and the team and the IRC council itself. And then what we did was we did a few pilot projects to demonstrate the efficacy of the polymers, because 2013 SP98 code was built with carry bags. Now that carry bags are banned, now you have multi-layered plastics, the packaging material, which are prevalent. So these multi-layered plastics have different types of polymers at different melting points, including aluminium as a barrier material. So we wanted to address that very well. So we have employed the CRRI for a comprehensive evaluation under Dr. Ambika Bell to evaluate this with 6%, 8% addition, 6%, 8% reduction of bitumen, so on. And probably by December end, we will have a comprehensive report, which will be sent to you, Doctor, because you have been in the last 20 years, along with Professor Veeraraghavan, doing a lot of work with plastic waste in roads. So being a pioneer, we will send it to you for your consideration. And then we want to table it to the IRC committee to properly consider the use. And also, we are also working with Aman India, Apollo Aman, which you know of, for a retrofit equipment, which will be trialed at Noida. The machine is ready, the site is ready, everything is ready. Because of NGT clearance, we are not able to carry on with that work. That's an excellent equipment which transfers the waste plastic, shredded waste plastic. As you said, the jugaad has been scientifically done now. So we are trying to demonstrate it. We will invite you also, sir, for that project. So you can see that through the retrofit, through the counterflow process in the drum mix plant, the plastics will be added. And we will ensure that it is not getting burnt, but it's getting excellently coated. Now CRRI has already told me the coating of the plastic is phenomenal, and there is a considerable reduction in the water penetration index as well as the saturated density. So I thought I will make it a point to tell you, sir, today. It's an opportunity for me to tell you also. So hopefully by this month end, we will have a report clearly defining the role of plastic, the appropriate polymers, as well as the leaching and emission reports and so on and so forth from the CRRI will be tabled to you as well as to the IRC committee.
Thank you very much. In fact, I just wanted to mention this. Somehow I just skipped that in the last IRC council, I think Apollo and Aman, they represented, and then they also informed that they are in the process of developing a system in the upcoming plants wherein there will be a provision for adding waste plastic onto the heated aggregates. If once that comes out, all this local jugaad may not be required, but that will be available only for new plants, as I hope. Otherwise, it will have to be a separate retrofit kind of a device which can be fitted with the existing plants. We have a large number of existing plants which are not likely to be replaced in next 5 to 10 years. So we have to take care of those plants as well, and that will be taken care by probably by this kind of the local jugaad, which we are also still working on its further improvement, because it is very cost effective, not costing more than 3-4 lakhs of rupees. So any contractor, local contractor in rural areas can make use of it. At the same time, in order to see the performance of the roads constructed with waste plastic, a project has been assigned to IIT Chennai. Professor Veeraraghavan is leading the team, which consists of around 8 principal investigators from various NITs and IITs. And I hope this project report will be out somewhere. Actually, the project was supposed to be completed in March 21, but because of COVID, we may have to give them an extension of minimum 3 to 6 months. So by 21st December, you can say, December 2021, we will get the outcome of this project, which covers a large number of roads laid with waste plastic and cold mix technology. Because our roads are having a thin bituminous surfacing, only 20 millimeter thick bituminous carpet, the effectiveness of waste plastic in reducing the penetration of water probably will be brought out in this project report. And then with confidence, we will be in a position to further develop the specifications even for higher order roads, which are now coming up even in PMGSY, because many of the earlier constructed roads are now fetching higher traffic volumes. So we are upgrading them even to intermediate lanes where bituminous macadam or even DBM is being laid, and then bituminous concrete is also being laid over it. So on bituminous concrete, still not many trials have been done, not many kilometers have been laid, though the Ministry of Road Transport has made it mandatory, but still it is in very initial stages. So we will be taking it up once the plant, as you said, that it will be available, plant for mixing of waste plastic, because that is a huge issue. Now
Doctor,
there
to
are
add to the point,
many material suppliers who have come up and who really speaking have gathered sufficient experience for collection and processing of this waste plastic. So there people are aware which plastic is to be included and which plastic not to be included. Particularly the thermoplastic, which you said, reused plastic, thicker plastic, which do not melt at 170, 175 degrees centigrade. So they are aware of it, and they are only using either the plastic bottles and their caps or the polythenes, threading it out, packing it in cement-like bags of 25 kg or 20 kg, and the contractors are directly procuring from there. Tamil Nadu and Madhya Pradesh are good examples where the waste plastic, threaded waste plastic production has come up almost in the form of a local industry. And wherever the waste plastic is available, there are a couple of suppliers who are procuring this, threading it, cleaning it, and then supplying it to the contractors. So I hope in the days to come, this will come up as a technology which will have a foolproof mixing system for mixing in the hot mix plants as well.
Doctor, Doctor, two more points which you said I want to make a rejoinder. One is the Amman equipment, the Jugaad machinery. Now, Amman has promised us, because we have signed a collaborative arrangement with Amman. So they have promised that they would be giving this retrofit equipment for all the 15,000 drum mix plants at a very, very low price. All they want is an annual maintenance cost. So they might be giving it at a very, very low price compared to a Jugaad, and for all the 15,000 drum mix plants available in the country for use of waste plastic.
That is great. If that comes, I hope the entire plastic will be used, and we will not see the scenario of littering of plastic here and there, because now many people who are who were earlier working as rag pickers here and there, now that has come in the form of an industry. And many self-help groups have come forward who are taking this as a business case. You can see this in many areas of Tamil Nadu. Huge number of suppliers are there. So at least people are getting some kind of the job through it, and we are getting rid of the environmental damage being caused by the plastic.
Yes, Doctor. And one more thing, very quickly, we are the first company to have ever launched a brand for waste plastic in India called Reroute. So this is the first time a branded waste plastic packaged and perfectly with technical agreement it has already been launched. So we will be taking a marketing exercise after the CRRI report. So we will be giving it very competitively to all the contractors in a Reliance assured product for the first time.
Thank you, Doctor. That is good.
Thank you, Doctor. Thank you.
I take this opportunity to thank vigorously to our learned speaker, and Dr. Pateria ji spared time. Even being in the meeting, he acceded to our request, and on behalf of Rajasthan Technical University and on my personal behalf, on behalf of State Technical Agency, Rajasthan Technical University, I extend my warm thanks and gratitude to him, and thank you once again, sir. And we will invite you sometime in our university to interact with our this journal engineers. You had come to Udaipur in the workshop. I missed that. I was planning to join, but at last moment I had some work. So next time, whenever you come to Rajasthan, we will try to have a meeting with you, sir.
Thank you, Professor. Thank you.
Thank you so much once again, and I thanks Dr. Narayanan also for his inputs, valuable inputs.
Thank you, sir.
So with this, with your permission, Dr. Pateria sir, I close this session.
Thank you. Thank you.
Thank you very much, sir. For participants, there is an announcement. We will be back at 2:55 p.m. With the session on stress management. So please be back with a quick lunch, and we will be back at 2:55 p.m. From 3 p.m. sharp, the session is scheduled to start. Thank you all for joining us and keeping with us, being with us. Thank you all.